we didn't complete the numericals from the second chapter. So we have to do the numericals from the second chapter. Let's begin. Which was the question we are discussing the last? Do you have this worksheet with you? This worksheet, or motion in a straight line worksheet. Sana, Sneha, do you have a motion in a straight line worksheet with you? Sana, Sneha, do you have that worksheet?
No, sir.
I will send the worksheet again. If you don't have that worksheet in the physical form, I will send the PDF in the group again. We will discuss that question. After completing the numericals, we will be continuing to the next chapter. Okay. Okay, that's our worksheet. That's our worksheet. There is 30 questions in it. In that worksheet, there is 30 questions in it. You don't have the print here, right? Joshua? You don't have this print? Okay, no problem. Which was the question that we discussed in the last? Did we discuss the question number 15? Displacement time graph of two particles A and B are straight lines making angles respectively 30 degree and 45 degree. Did we discuss that question? Do you remember that question? Tell me, Sneha. Sneha, Sana, did we discuss that question? Do you remember that one?
Sir, which question?
Question number 15. Question number 15. Have we discussed question number 15? Question number 15. From motion in a straight line. Question number 15. Have we discussed it, Joshua? Do you remember that?
Sir, I think we have discussed this question.
Yes. In my memory also, we have discussed that.
Yeah, I remember we were finding ratio of something.
Yeah, yes. Good. That's the question. Then there is another question number 16. We will start with question number 16. Whatever, even if it is, we have done that question in the classroom, or no problem, or otherwise no problem. Just look at question number 16. We have to do question number 16. Just read the question. What is the question? Velocity time graph of two objects. Velocity time graph of two objects make angle 30 degree and 60 degree with the time axis. Okay. Find the ratio of their acceleration. Find the ratio of their acceleration. Ratio of acceleration. Ratio of acceleration. We may have done this question, but no problem. I'm doing it anyway. Okay. So there is a velocity time graph. There is a velocity time graph. So this will be velocity and this is time. And two objects are there. Two graphs are there. Two objects make angle 30 degree and 60 degree with the time axis. So this is the time axis. Now we have the two graphs. This is, I'm taking it as A. It is making 30 degree with the time axis. Okay. And there is another one which is making 60 degree with the time axis. I'm taking it as B. I'm calling it B. So there is two graphs. Graph for A and graph for B. A is making 30 degree with the time axis and 60 degree. B is making 60 degree with the time axis. Is that okay? And what are they asking for us to find? Find the ratio of acceleration. How can you get acceleration from this graph? Yeah, we have done this question, right? And 18th question also. Do you remember 18th question? A lives closer than B. That question. There is a graph question in question number 18. Can you see that? Question number 18. There was a graph question. We have done that. I remember that doing that in the class. Okay. Anyway, I have started this question, so I will complete it. And you have to find the ratio of acceleration. How can we do that? Ratio of acceleration. What is acceleration? What is acceleration? Yeah, this is velocity time graph. So acceleration will be equation for acceleration is v minus u by t. So acceleration means v minus u means you will get a velocity here, another velocity here. That's v minus u. So the v minus u will be y here, because the component on the y-axis, and the t is on the x-axis. So this is y by x. Acceleration is y by x. That means, what is this y by x? Y by x is slope. Slope is y by x. Or tan theta. Or tan theta is y by x. Slope is y by x. Or tan theta is y by x. So if you are finding the slope of this one, if you are finding the slope of the graph, you will get acceleration. So acceleration of A will be what? Acceleration of A. Acceleration of A. Acceleration of A will be slope of A. Acceleration of A will be slope of A. And how can you find acceleration of A? What is slope of A? Tan theta or tan 30. That's slope of A. Tan 30. What is tan 30? Tan 30 is 1 by root 3. Tan 30 is what? Tan 30 is 1 by root 3. So you can write 1 by root 3. That's tan 30. That's acceleration of A. Then what is acceleration of B? Acceleration of B. Acceleration of B. What is acceleration of B? Yeah, acceleration of B will be tan 60. Good, tan 60. That is acceleration of B. Velocity change divided by time. That will give you acceleration of B. Then what is tan 60? Tan 60 is root 3. Tan 60 is root 3. So acceleration of B is root 3. Now you have to find the ratio. You have to find the ratio. How can we find the ratio? How can we find the ratio? Acceleration of A divided by acceleration of B. You will get the ratio. What is acceleration of A? Acceleration of A is 1 by root 3 divided by, what is acceleration of B? Acceleration of B is root 3. Yeah? Okay. How can you find this? How can you solve this? This is what? 1 by root 3. Take the reciprocal and multiply. That's reciprocal of root 3 will be root 3. 1 by root 3. Reciprocal of root 3 will be 1 by root 3. So 1 by root 3. That's root 3 by 1. If you take the reciprocal, that will be 1 by root 3. And 1 by root 3, 1 by root 3, when multiplied will give you root 3 into root 3. What is that? 3. Yes, good. Then that's 3. So acceleration of A divided by acceleration of B is what? 1 by 3. That's 1 by 3. Hi, Arpita. Okay, that's 1 by 3. And we have just repeated the question. We have already done that question in the class. And question number 17, we have done it. Question number 18, we have done it. And we have to do question number 19 now. We have done question number 19 in class, haven't we? Different types of graphs. Different types of graphs and analyzing those graphs. We haven't done that in my memory. Okay, then I am moving into question number 19. Question number 19. Just look at question number 19. and read it. Because look at the graphs A to D. There is graphs. There is graphs from A to D. A to D. A, B, C, D. Four graphs are there. State with the reasons which of these cannot possibly represent one-dimensional motion of a particle. Which of these graphs cannot represent one-dimensional motion of a particle? That is the question. Did you understand the question? There should be a graph in the question. I will give you the first graph. What is the first graph? In the first graph, it is a position time graph. That's a position time graph. So x here, t here, x here, t here, and the graph is looking like this. Graph is looking like this. This is the shape of the graph. Graph is looking like this, and the motion, the direction is shown like this. The direction is shown like this. Tell me, is this graph possible or not? For one-dimensional motion, is this graph possible or not? This is time and this is position. As time increases, position is changing. As time increases, position is changing. Here that you can find from the graph. The position is changing. But my question is this graph represent one-dimensional motion? Motion along a straight line? No. This graph cannot represent one-dimensional motion. Why is that? Let me tell you one thing. If you are taking a particular time, if you are taking a particular time, I'm taking this time. At this time, the position is at this point, right? Right? But at the same time, you can extend that line and you will get another position also. What is the meaning? At the same time, you have two positions. Is that possible? Is that possible? No, that's not possible. That's not possible at the same time. Let's say T1. At T1, you have two positions. That's not possible. So this graph cannot be a graph of one-dimensional motion. Did you get it? So you can draw this graph. Make it a little bit speedy. Draw this graph and write. After drawing that graph, we have to write a simple note for that. Have you drawn it? Yeah. Then write below that. It is not a graph of one-dimensional motion, or it is not representing one-dimensional motion. 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 It's not representing one-dimensional motion. At a given instant of time, particle has two different positions. Particle has two different positions. Particle has two different positions. At a given instant of time, particle has two different positions. It is not possible in one-dimensional motion. 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 Not possible in one-dimensional motion. Now look at the next one. Now look at the next one, the next graph. Please look at the next graph. There is velocity on y-axis and time on x-axis. Velocity on y-axis, time on x-axis, and the graph is like this. Graph is like this. Is this graph representing one-dimensional motion? What is your answer? What is your opinion? Is the graph representing one-dimensional motion? No, it is not one-dimensional motion. Why is that? Why it is not one-dimensional motion? The same reason goes here also. Yeah, for a particular time. Yeah, no, not the same level, not the same one. Huh? Let's look about this time here. Yeah. This time here. What is the speciality of that point? If you are extending it, you will get not two positions. Here you have two positions, two different positions for one single time. But here the reason is you will get two velocities. You will get two velocities for a single time. That's not possible. At a single time, there is two velocities, which is not possible. So you can say this is not representing one-dimensional motion, right? So please write, draw the figure, and below the figure, write not in one-dimensional motion. Not in one-dimensional motion. Not in one-dimensional motion. Right? At a given instant of time, at a given instant of time, particle has different velocities. Particle has different velocities, which is not possible. Which is not possible. You got it? Which is not possible. Okay? Have you finished it? Arpita, Sneha, Sana?
Yes, sir.
Yeah. Can I move to the next page? Okay,
Yes, sir.
yeah. Then we have to see the next graph. That's graph number C. In graph number C, that's a speed time graph. Graph number C is a speed time graph. Look at the graph. Speed time graph. The graph is like this. Okay? The graph is like this. This is the speed time graph. Arpita?
Can you show the previous slide for a minute?
Yeah, okay. This is not in one-dimensional motion. At a given instant of time, particle has different velocities. You can see one velocity here, another velocity here. So particle has different velocities, which is not possible. Particle has different velocities, which is not possible.
Okay, sir.
Okay. Then third one. What about this graph? Can you tell me about this graph? Is this graph possible for a one-dimensional motion? Why is that? At this time, take this time. It has different velocities or different speed? No, it does not have different speed. Only one speed for one time. So that's not the reason. That is not the reason here. Then what is the reason? Time? No, time is never negative because time is on x-axis. Right? Time negative means what? This is negative x-axis. But time negative means what? Yeah, time negative means the particle has already started the journey. That is the meaning of time negative. Okay? Time zero means we have just observed it. You have just observed it. We have just started observing it. Okay? Before that, it was moving. Right? So the reason lies in speed. Speed is a scalar quantity and it can never be negative. That's the reason. It's a scalar quantity, it can never be negative. Right? It can never be negative. And please write the reason. Not in one-dimensional motion. Not in one-dimensional motion. Not in one-dimensional motion. Why is that? Why is that? Speed can never be negative. Speed can never be negative. Speed can never be negative. That's right. Speed is always positive. Speed is always positive. Speed is always positive. Speed is always positive. It cannot be negative. So in this figure, you can see speed is becoming negative. That's not possible. The negative speed is not possible. That is the reason. And now we have to see the fourth graph. We have to see the fourth graph. Fourth graph is total path length. Fourth graph, in y-axis, you have a total path length. In y-axis, you have a total path length. In y-axis, what do you have? Total path length. And in x-axis, what do you have? You have a time on x-axis. You have a time on x-axis. And the graph is like this. The graph is like this. This is the shape of our graph. The graph is like this. This is the shape of the graph and this is 0. Okay. Is this graph possible for a one-dimensional motion? What is your opinion? Is this graph possible for a one-dimensional motion? This is total path length. What is total path length? Total path length. Length of the path. What is that? Yeah. Length of the path is distance. Total path length means distance. Total path length means that's distance. In the graph, they have given you the distance. Right? And as the time increases, you can see distance decreases. Is it possible for a moving object? Is it possible for a moving object? As time increases, distance decreases. No, distance can never decrease. If a particle moves, its distance is always increasing. For a particle which is in motion, its distance is always increasing. It should not decrease. You got it? That's the reason. So this is not in one-dimensional motion. Not in one-dimensional motion also. This is not in one-dimensional motion. What is the reason? Not in one-dimensional motion. What is the reason? Yeah, you can write the reason. In the graph, total path length decreases. In the graph, total path length decreases. Total path length decreases. In the graph, total path length decreases. Okay? Total path length can never decrease with the time. But total path length can never decrease. Total path length can never decrease. Total path length can never decrease with time. Total path length can never decrease with the time. Can never decrease with the time. Total path length can never decrease with the time. That's our answer. That is our answer. Tell me when you have finished. What about you? Arpita, Sneha, Sana? Did you finish it?
No, sir.
Yeah, okay, take your time. Complete it. Joshua, just look at question 20. Try to understand that question. Is it over? Can I go to the next question? Arpita, Sana, Sneha?
Yes, sir.
Yeah, okay. Okay. Then look at question number 20. Question number 20. In that question, the velocity time graph shown below represents the motion of an object. So you have a velocity time graph. So draw the corresponding acceleration time graph. That's a very simple question. You have a velocity time graph. You have a velocity time graph. What is this? That's a velocity time graph. So I am redrawing the velocity time graph here. Okay. And it is starting from A. It is starting from A. This is the point A. And it has reached this point B. At the point B, you have a velocity 15 meter per second. You have a velocity 15 meter per second. At the same time, you have a time 2 seconds. Okay, and it is the velocity is not changing from B to C. The velocity is not changing from B to C. C is corresponding to a time 5 seconds. C is corresponding to a time 5 seconds. And there is a 6 second there. And the object comes to the velocity of object becomes zero when it is at a time 6 seconds. When it is at a time 6 seconds. So that's A, B, C, D. A, B, C, D. You have a velocity time graph. Now you have a velocity time graph. What do you have to plot? Acceleration time graph. You have to plot an acceleration time graph. So I am drawing a graph below. I am drawing a graph below. This is acceleration time graph. Acceleration time graph. Acceleration in meter per second square. Right? What are the time points though? The time points are extended lines. This is 2. What is this? This is 5. What is this? This is 6. So this must be 2, 5, 6. This is 2, 5, 6. You got it? I have extended the timelines. I have extended the points in time. And just look at the graph. What is happening from A to B? What is happening from A to B? From A to B, velocity is increasing. If velocity is in a straight line, it is increasing. The slope will give you acceleration. And the slope is a constant curve. The slope of the graph is not changing because it's a straight line. Right? It is a straight line. So the slope is not changing. That means the acceleration is no. Acceleration is not increasing because slope is a constant. So acceleration is a constant. That means you will have an acceleration like this. You will have an acceleration like this. This will be the acceleration. Okay. And at T, this is the point A. And from point A, you will have an acceleration like this. And what is happening after that? When the particle is from 2 to 5. 2 to 5. What happens to particle? What happens to the velocity? Velocity is not changing. Velocity is a constant. If velocity is a constant, acceleration is. If velocity is a constant, what is the value of acceleration? Constant? No. Velocity is a constant means acceleration is v minus u by d. If velocity is a constant, then acceleration must be 0. Velocity is not changing. Velocity is not changing. V minus v divided by t. That will be 0. If velocity is not changing, then acceleration is 0. If like this, what is a acceleration? Acceleration is equal to dv by dt. Acceleration is equal to dv by dt. What is dv? What is dv? dv is what? dv is change in velocity. What is change in velocity here? That's 0. If change in velocity is 0, acceleration is 0. Right? If change in velocity is 0, acceleration is 0. You got it? So, change in velocity is 0 because velocity is a constant. Then acceleration will be a 0 value. So, this is the acceleration. Acceleration comes to 0. Now, acceleration is 0. Okay? From 5 to 6, what happens to acceleration? From 5 to 6, what is happening in velocity time graph? Velocity has a negative slope. What is negative slope? Velocity is decreasing. Velocity is decreasing. If velocity is decreasing in a constant manner, what will be acceleration? If velocity is decreasing, at that time acceleration is called retardation. Do you remember that? Acceleration is called retardation. If velocity is decreasing, then acceleration is called retardation. It will have a negative slope. Velocity decreasing, it will have a negative slope. Now the CD line will have a negative slope. If it has a negative, say CD, the line CD has a negative slope. If it has a negative slope, what is the meaning? Yeah, acceleration is negative. Acceleration is negative. What is retardation? Yeah, retardation is negative acceleration. Okay. What is retardation? Retardation is negative acceleration. Negative acceleration. Retardation is negative acceleration. So, from C to D, you have a negative acceleration or retardation. Right? From C to D, you have negative acceleration or retardation. How can you represent a negative acceleration? Yeah, down. Good. Down. You will have a value of acceleration. This is your graph. Now this is your graph. Okay? The graph looks like this. Graphs look like this. It is 0 here, no acceleration. Then the acceleration is negative. Then the acceleration is negative. This is our acceleration time graph. This is our acceleration time graph now. Did you understand that? Joshua. Okay, what about you, Arpita, Sana, Sneha? Did you guys understand that?
Yes, sir.
Yes, sir.
Okay. Can I move to the next one?
Yes, sir.
Yeah. Okay. Then look at the next question. Question number 21. Question number 21. In the given VT graph, what is a VT graph? Velocity time graph. In the given VT graph, find the distance traveled by the body in 5 seconds. Find the distance traveled by the body in 5 seconds. Also find the displacement of the body in 5 seconds. You have to find the displacement and distance from the graph. From the graph, you have to find the distance and displacement. Can we do that? Huh? Okay. Let's try question number 21. Question number 21. I will read now the graph here. This is our graph in the question. That's a velocity time graph. So velocity is represented on the y-axis and time is represented on the x-axis. And you are starting from the 0, 0, 0. You are starting from 0, 0. And you have a point here, 20. 20 is there. And you have another point here, that's 40. Another point here, that's 40. Okay? And you can extend this 20 parallel to the time axis. And the graph starts from 40. The graph starts from 40. And the graph is slope like this. Negative graph has a negative slope like this. And at the negative slope, you will get a time 2 seconds. So here you have 1. Okay? And from 2 to 3, from 2 to 3, there is no change in velocity. Velocity is not changing from 2 to 3. From 2 to 3, velocity is not changing. From 3 to 4, from 3 to 4, the velocity is decreasing. From 3 to 4, the velocity is decreasing. From 4 to 5, from 4 to 5, I will extend the time point 5 like this. From 4 to 5, the velocity is decreasing but in opposite direction. Decreasing but in opposite direction. And this is the extension of the axis. And at this point, you have another 20. At this point, you have another 20, but that's minus 20. So the velocity has a negative value. The velocity has negative value. That means no. What is this? This velocity, the velocity has 0. The velocity has 0 value here. And after that, the velocity is increasing in opposite direction. Yeah, this is negative. So the velocity is increasing in opposite direction. It is like that. Velocity is increasing in opposite direction. You got it? Okay. Here the velocity is decreasing from C to D. I will name the points. This is the point A, B, C, D, E. Now from C to D, velocity is decreasing. Velocity is decreasing. And at D, the velocity has become 0. Okay? Then the particle is beginning to increase its velocity in the opposite direction. Right? So that's this graph. Did you understand this? So let's see what do you have to find the distance traveled by the body in 5 seconds. What is the distance traveled by the body in 5 seconds? Distance traveled. How can you find distance traveled from velocity time graph? How can you find it? Arpita, Sana, Sneha, what is distance traveled from velocity time graph? Guys, Arpita, Sana, Sneha, what is distance traveled if you have a velocity time graph? No, from the graph. From the graph, what quantity is equal to distance traveled?
Speed into time.
No. Distance traveled, you can find the value of distance from the velocity delta, and the distance will be equal to area under the graph. Okay? Distance will be equal to distance traveled is equal to area under the graph. Area under the graph. Do you remember that from the derivation? We have derived the equation S is equal to ut plus half at square from a velocity time graph. Do you remember that? When we were doing that derivation, we used this idea. Distance traveled will be equal to area under graph. Do you remember that? Okay, then distance traveled is area under graph. You just find the total area under this graph. You will find it. You will find the distance traveled. So you can find the distance traveled. What is distance traveled? You have a one area here, two here, three. One area here, two here, third area here, fourth area here, fifth area here. You just find the areas and you just add them. You will get the distance traveled. Okay. So what is distance traveled? Distance traveled. Distance traveled is equal to, what is the area? Area of this triangle. Area of this triangle. Area of the triangle. What is that? How can you find the area of this triangle? Area of triangle is half BH. Area of triangle is half BH. Half BH. The area of the triangle is half BH. This is a rectangle. Huh? This also is a rectangle. What is the area of rectangle? Area of rectangle will be length into breadth. Right? Length into breadth. That's area of rectangle. So you can find area of triangle and area of rectangle from here. What is half BH here? That's half into, what is B? From this point to this point. From O to B. What is that? 2. O to B is 2. So half into 2 into, what is H here? From 20 to 40. From 20 to 40. What is that? 40 minus 20. What is that? 20. 40 minus 20 will be 20. So this is first area. Plus, what is the second area? How can you find the second area? L into B. What is L here? L here. That's from 0 to 2. What is L? 2. 2 minus 0. That's 2. Length into breadth. What is breadth? 0 to 20. 20 minus 0. What is that? 20. So 20. Plus, take the next rectangle. This is from 2 to 3. What is the equation for area? Length into breadth again. From 2 to 3. From 2 to 3. What do you have as length? 3 minus 2. What is that? 1. Length will be 1 into, from 0 to 20. What is the breadth? 20. From 0 to 20, that will be 20 minus 0 or 20. Okay? That's the third one. Plus, now what is fourth one? Yeah, that's a triangle. How can you find the area of triangle? Half into B into H. What is the B here? From 3 to 4. 4 minus 3. What is that? 1 into H. What is the H here? From 0 to 20. 20 minus 0. What is H? 20. Plus, what is the next area? You have to find the area here. Half BH again. Half BH again. Half BH again. That will be plus half into, what is B here? And B here is 4 to 5. 5 minus 4. Just 1. Okay? Just 1. 1 into, what is H here? No. H is height. H is height. Area cannot be negative. Right? H is height. This is velocity. Velocity is becoming negative. Area cannot be negative. So H is from 0 to 20. 0 to minus 20. What is that? 0 minus minus 20. That's 20. Right? 0 to minus 20 means 0 minus minus 20. Right? Like this. 0 is the greater one. So 0 minus minus 20. So 0 plus 20. That's 20. Okay. So that's 20. And you will get a distance traveled. How can you do the calculation? This is 2 is gone from the equation. You have only 20 here. So 20 plus 2 into 20. What is that? 40. 40 plus 1 into 20. 20 plus half into 20. 20 and half can be cut. You will get to 10 here. So that's 10 plus 20 and half can be cut also. Okay. Cut also, so you will get 10 here. What is that? 1 into 10. 1 into 10 will be 10. So what is this whole value? 20 plus 40, 60. 60 plus 20, 80. 80 plus 10, 90. 90 plus 10, 100. So the distance traveled is 100 meter. The distance traveled is 100 meter. Did you understand that? The distance traveled is 100 meter. Did you guys understand that? Sana, Sneha, Arpita. Did you understand this one?
Yes, sir.
Okay, that's distance traveled. Okay, now we have to find displacement. Now we have to find displacement. How can we find displacement? Now we have to find displacement. Displacement. How can we find displacement? What is displacement? Displacement is again area. Displacement is again area. That's area under velocity. Area under velocity time graph. That's displacement. Area under velocity time graph is displacement. Distance and displacement has same dimension, right? So they will have a same meaning sometimes. Area under velocity time graph. Okay, we can add area. We can add area to find displacement. We can give S for displacement. But there is a slight problem. First area, you can add it. Yeah, you can add first area, no problem. 20 plus second area also, you can add it, no problem. So second area, 40 plus third area also, you can add. So that's 20 plus fourth area, you can add, no problem. What is 1, 2, 3, 4? What is the fourth area? That's 10. But the fifth area, what is it about the fifth area? What is happening from D to E? What is happening from D to E? What is happening to the particle from D to E? Its velocity is increasing. Opposite direction. That means it is returning. It is returning to its origin. It is returning to its initial point. Right? That means it has negative displacement. It has negative displacement. It is returning. So you should give negative area. If you are finding distance, you can simply add that. If you are finding a displacement, you have to consider whether it is positive or negative. Right? Because displacement is what? That's a vector. Right? Okay, so that area should be negative if you are considering displacement. Because the velocity is in opposite direction. The body is returning. Velocity negative means it is returning. It is in opposite direction. So what is the final value? 20 plus 40, 60. 60 plus 20, that's 80. Right? 80 plus 10, that's 90. So 90, no, simply. You can simply 10 minus 10 is gone. 10 minus 10 is gone. So you are left with the 2, 4, 2. 2, 4, 2, 80, right? It is 80 meter. It is 80 meter. So displacement is 80 meter. But distance is 100 meter. Displacement is 80 meter. Did you get it? Yeah. That's minus 20. This one. This one. The area here represents negative displacement. Okay. So we have to take it as negative. Where is minus 20? No, the minus 20 is the velocity value. Value of velocity. What are those? What is 20? No, that's an area. That's an area. Area of the first one. What is 40 here? Area of the second one. What is 20 here? Area of the third one. What is 40? Area of the fourth one. What is 10? 10 is area of fourth one. What is next to 10? That's area of the fifth one. But the fifth one is representing negative displacement because the body is returning. So you have to put a negative there. Then you will get that. Okay. Guys, Arpita, Sana, Neha, is it okay now?
Yes.
Okay. Then look at the next question. Question number 22. Have you completed it? Take the note. Joshua, have you finished? Arpita, Sana, Sneha, did you guys complete it?
No, sir.
Yeah. Then complete it and tell me. Look at the next question, Joshua. Try to understand it.
Sir, done.
Okay. What about you, Sana?
Sir, done.
Okay. Then we can move to the next question. Take question number 22. Take question number 22. What is in it? The acceleration time graph of a particle moving in a straight line is as shown in the figure. The velocity of the particle at the time t is equal to 0 is 2 meter per second. The velocity is given. What is that velocity? That's initial velocity because t is equal to 0. If t is equal to 0, the object is starting to move. Right? Or we are starting to observe it. Then that velocity is 2 meter per second. That's initial velocity. Okay, find the velocity after 2 seconds. We have to find the velocity after 2 seconds. What do you have here? We have an acceleration time graph. This is meter per second square. This is time. We have an acceleration time graph, and the graph is very simple like this. Here you have 0. At this point you have 1. Here you have 2. And this point is corresponding to 4 meter per second square acceleration. And the velocity of particle at a time t is equal to 0 is given. At t is equal to 0, velocity can be taken as initial velocity. Velocity can be taken as initial velocity. So the initial velocity is given as 2 meter per second. The initial velocity is given as 2 meter per second. Okay? And find the velocity after 2 seconds. What is the velocity after 2 seconds? That's the question. Okay? I will tell you how to do this question, how to solve this question. Just look at this graph. Look at this graph. If we are considering a rectangle in that graph, what will the graph give you if you are finding the area? What is the area of this rectangle? What is the area of this rectangle? Now I'm not talking about the value. I'm not talking about the magnitude. I'm just talking about the parameter. Which quantity will be the area? What is area? Area of the rectangle will be length into breadth, right? So what is length here? No, I am not talking about the value, but the quantity. What is the quantity that is equal to length here? Time. It is in x-axis. So that's time. Time into what is the quantity that is equal to breadth here? Acceleration. So acceleration into time. What is acceleration into time? Which quantity is acceleration into time? Can you guys tell me? Arpita, Sneha, Sana, which quantity is acceleration into time? Which quantity will be acceleration into time? Can you tell me? Which quantity? Acceleration into time. That's very simple actually. No, that will not give you distance. Look here. You have equation for acceleration. A is equal to v minus u by t, right? If you are bringing the t to the other side, that will be acceleration into time. Then that is velocity change. So what is the acceleration into time? That's velocity change. Acceleration into time will be velocity change. Did you understand that? Acceleration into time will be velocity change. So area, that's acceleration into time. And what is area? Area is velocity change. Area is velocity change. Velocity change. Change in velocity is area. Right? Change in velocity is area. So you will get area as velocity change. What is area? Area is velocity change, right? And you just find the area and you will get a velocity change. What is velocity change? Just find the area. What is the area? This is a triangle. So what is the area? Yeah, area of triangle. What is that? Area of triangle. That's half BH, right? Half BH. So half into B into H. What is B here? Base. Base is 0 to 2. 2 minus 0. What is that? 2. So half into 2 into H. H is from 0 to 4. 4 minus 0. What is that? 4. So H is 4. And this 2 is gone. This 2 is gone from the equation. 2 is gone from the equation. And you will get what is V minus U? V minus U is 4. What are you getting? V minus U is 4. And in the question, the value of U is given. What is the value of U? That's 2 meters per second. So V minus 2 is equal to 4. Then what is V? What is V? Yeah, what is V? V will be 4 plus 2. If you are bringing this minus 2 to the other side, that will be plus 2. So V is equal to 4 plus 2 and V is equal to 6 meters per second. This is the velocity at 2 seconds. That's the velocity at 2 seconds. Find the velocity after 2 seconds. That's what we have to find. So this is the velocity after 2 seconds. Velocity after 2 seconds. This is the velocity after 2 seconds. Did you understand that? That's the velocity after 2 seconds. What about you guys? Arpita, Sana, Sneha? Did you guys understand this question?
Yes.
Yeah. Can I move to the next one?
Yes, sir.
I didn't get it.
Yes, sir.
Okay, thank you. Then I am going to the 23rd question. 23rd question. A car moving along a straight highway. A car moving along a straight highway with the speed of. I am just drawing a rough figure of that car. A car is moving along a straight highway with a speed of. What is the speed? What is the speed? 126 kilometer per hour. Is brought to stop within a distance of 200 meters. So in a distance of, I can take it as S, displacement, because this is a straight line. In a distance of 200 meters, it is brought to stop. What quantity lies there? Which quantity will be getting from the idea the car is stopping? Huh? No. Which quantity will be given if they are saying the car has stopped? If the car has stopped, the final velocity will be zero. The car has stopped, the final velocity will be zero. V will be zero. Okay? So V will be zero. And what is the retardation of the car? What is the retardation of the car? What is the retardation? That's acceleration with a negative sign. That is retardation. What is the retardation of the car and how long does it take for the car to stop? What time? With what time the car will stop? With what time the car will stop? That's the question. How can we do this question? How can we do this question? We have Vs and speed also. Now, you can take this as velocity because this is in a straight line motion. But you cannot take this quantity directly because it is in kilometer per hour. You have to convert that into meter per second. How can you convert that into meter per second? How can you convert that into meter per second? Just multiply that value with 5 by 18. 5 by 18. You can convert that into meter per second. Okay? And 18, 126. 18 and 126. Just look at 18 and 126. What about 7? 18 into 7. Yeah, 18 into 7 will be 126, right? So you can cut 18 and 126. That will give you 7 here. So 7 into 5, what is that? 35 meters per second. So our velocity, our initial velocity is actually what? 35 meters per second, because the car is moving with that velocity, and that velocity is what? 35 meters per second. So you have to write that velocity in meter per second. You should not do the calculation using this equation. You should not do this calculation using this equation. You have to convert that into meter per second. Did you get it? So you have converted it to meter per second. Now you have V U. You have V U S, and you have to find A. What is that equation? With what equation you can find A? With what equation you can find A? We can use this equation. V square is equal to U square plus 2AS. V square is equal to U square plus 2AS. What is V square now? That's 0. What is U square? That will be 35 square plus 2 into A into S. What is S? S is 200. S is 200. What is 35 square? 35 square. One, two, two, 5, right? 35 square is 1225. So 1225 plus 200 into 2 will be 400. 400 into 8. That's 0. Okay, you can find A by just leaving this 400A on one side, bring this 1225 to the other side, that will be minus 1225, minus 1225. Or you can simply write this like this also. Minus 400A will be 1225. Then what is A? What is A? A will be 1225 divided by minus 400. What will be the value? 400 into 3 will be 1200. So that will be 3 point something. I am taking it as 3. I am not dividing it, I am taking it as 3. Okay? 400, 1200 divided by 400 will be 3. So minus 3 meter per second square. That's acceleration. Did you get the acceleration now? That's our acceleration. That's our acceleration. So we have found the value of acceleration. We have found the value of acceleration. And what about time? How can we find time? With what equation we can find the time? With what equation we can find the time? We have this equation V is equal to, and use another color. We have another equation also. What is another equation? V is equal to U plus AT. There is T in it. So you can use this equation. And what is V? V is becoming 0. What was U? U was 35. U was 35. Acceleration is minus 3. So minus 3 into T. Minus 3 into T. So that's 0. 0 is equal to 35 minus 3 into T. Then what is 3T? 3T will be 35. What is 3T? That's 35. Then what is T? What is T? What is T? T is 35 divided by 3. What is 35 divided by 3? 35 divided by 3. 3 into 11 will be 33. 3 into 11 will be 33. So 3 times 11. That means T will be 11 point something. There will be point something. I am not taking the point. So 11 seconds. And rounding it off. I'm taking just 11. So T will be what? 11 second. Within 11 second, the vehicle will come to a stop. If the vehicle has this speed, if the car has 126 km per hour speed, and that is brought to rest in this distance, then that will take 11 seconds to stop that car. That will take 11 seconds to stop that car, and the acceleration of the car will be minus 3 meter per second square. Minus 3 meter per second square will be the acceleration. Did you get it? Guys, Arpita, Sana, Sneha, did you understand that?
Yes, sir.
Okay. Then we can take a very small break. Most of you are online, so I am not planning for 10-minute break. We can just take a 5-minute break, and we will continue after that.
Okay, sir.
Yeah. It's about 5:45, so we will continue our class at 5:50. Is that okay, Joshua? Did you understand this one? Can we continue? Arpita, Sana, Sneha, are you guys there?
Yes.
Yeah. Then we can continue the session. We have done question number 24 in my memory, right? Question number 24. A ball is thrown vertically upwards with a velocity of 20 meters per second. We have done that question in my memory. Do you remember that question? Question number 24 about the vertical motion. Question number 24. Huh? Have we done that question? Question number 24. Just check your notebooks. Check your notebooks and tell me if we have done question number 24. Sorry, 23. Check if we have done question number 23. Have we done that? Just check your notebooks.
So question number 23, we just did it right.
We have done this. Yeah. Question number 23, we have already done that. So I am going to question number 24. What about question number 24? So, no. We just did 23. And what about 24? I was asking for 24. I was referring to 24. Have you done question number 24? Just check your notebooks. Check your notebooks and tell me if we have done question number 24. Check your notebooks and tell me if we have done question number 24. A ball is thrown vertically upwards with a velocity of 20 meters per second from the top of a multi-story building. That question. There will not be any question in your notebook that will. Maybe you have written the question also. Just check it in your notebook and tell me. Arpita, Sana, Sneha, have we done this question before? Yeah, right. So we have done question number 24. And what about question number 25? Question number 25. A ball is thrown upward from the top of a tower 40 meter high and velocity 10 meters per second. Find the time taken to strike to the ground. We have done it. Okay, then that's okay. That's over. Question number 25 is okay. What about question number 26? Yeah, we have done that. That's a little bit complicated question. That's a little bit complicated question. What is that question? A ball is thrown upwards. Okay. Should I write the question on the board or you will look at the question? Arpita, Sana, Sneha, should I write the question on the board?
No, sir, we have the question.
Yeah, okay. Then we will look at question number 26. A ball is thrown upwards from the ground. Okay. From the ground, a ball is thrown upwards. Ball is thrown upwards with the initial speed of u. With the initial speed of u. So what is u? U is the initial speed or initial velocity. U is initial velocity. The ball is at a height of 80 meters at 2 times. Right? The ball is at 80 meters at 2 times. What is the meaning of that? The meaning of that, this is the point which is corresponding to 80 meters. Okay? This is the point which is corresponding to 80 meters. And the ball is at that point 2 times. Then what is the meaning of that? The ball has reached this point and calling that point as A. What is happening to the ball then? The ball is reaching its maximum position somewhere here, maximum position. Then it is coming back. At this point B, it is again meeting the 80-meter distance. Right? That is the meaning of the question. So the understanding the question is very important. So you have to give some space to write the question. After that, we can answer this. You can give some space for that question. After that, we can solve this question in the notebook. You should give some space for the question. Question is very important. So, when the object is at A, it has traveled 80 meters. When the object is returning back, and it is at B, it is again from ground. It has a displacement of 80 meters. It has a height of 80 meters. That's the question. And the time interval being 6 seconds. What is the time interval being 6 seconds means? The time interval when the particle is meeting this 80 meter is 6 seconds. Okay? The time interval for the ball to meet this 80 meter is 6 seconds. That is the question. Find u. What is u? That's the question. Find u. That's the question. It's a different type of question. It's a different type of question. You will not get it very simply. But if you understand the method, you can solve the such type of question. You can solve such type of question. How can we do this question? How can we do this question? Just we have only one data here. Only one data at this point. What is that data? The distance traveled. Then what is the equation for distance traveled? The equation for distance traveled S. S is equal to ut plus half at square. So what is S? Yeah, S is 80 meter here. Right. The distance traveled is 80 meter here. This is O from A, from O to A. That's 80 meters. So 80 is equal to ut. We don't know that time. Okay. Ut plus half. Or what is this A? What is A? This is upward motion. We have taken velocity as positive. If the velocity is positive, acceleration is always towards the earth. So acceleration is minus g. Acceleration is minus g. So half minus half g t square. You can take the value of g as 10 meter per second square. No problem. So 80 is equal to ut. If this is 10, then that will be into 10 t square. You can strike 10 and 2, and you will get 5 here. You will get 5 here. So what is this? 80 is equal to ut minus 5 t square. Ut minus 5 t square. If you are bringing this term minus 5 t square to the other side, you will get 5 t square here, right? Minus 5 t square will become plus 5 t square. If you are bringing this one, that will be minus ut, and there is already an 80 there, so 80 is equal to 0. You have a quadratic equation here. You have a quadratic equation here, and you have to find the value of t from that. You can find the value of t from this quadratic equation. There is no other data given to find t. There is no other data given to find t. There is only this data to find t. So you can solve this equation to find t. This is like a quadratic equation, ax square plus bx plus c. This is like this equation, ax square plus bx plus c is equal to 0, which is like this equation. Okay, so we can solve this equation. How can we solve this equation? How can we solve this equation? We have the equation for x. What is the equation for x? X is equal to minus b plus or minus root of b square minus 4ac divided by 2a. Do you remember this one? Do you remember this one? This is our equation to find x. Like that, we can find the value of t from here. So you have a, this is a, this is b, this is c. You can find the value of time t. What is t? T is minus b. Okay, minus b. What is minus b? B is minus u. B is minus U. So you can write minus U here. Minus U. Did you understand why there is 2 minus? In the equation there is a minus. Minus of B. Minus of B. So minus of B. What is B? B is this one. This is B. Minus B. Okay? Minus B plus or minus root of B square. What is B square? Minus U square. That's minus U square. B square minus 4 into A. What is A? 5 into A into C. What is C? That's 80. Divided by 2A. What is that? 2A. 2A. What is 2 into? Yeah, 5. Then what is T? T is minus of minus. Plus U. U plus or minus root of minus U square. Yeah, U square. Minus U square will be U square. U square minus 4 into 5 into 8. What is that? 4 into 5 is 20. 20 into 80. 16. 2 zeros. So this is it. Okay. Divided by 2 into 5, 10. So this is the value of T. Now concentrate very carefully. If you have an equation for time or an equation for x, then the first value of x will be here. Then the first value of x will be here. Then the first value of x will be here. So the first value of x will be here, and the next value of x will be here. Okay, the first value of x will be here, and the next value of x will be here. What is the first value? U plus or minus something divided by something. So the first value and the two values will be u plus something, u minus something. U plus something is one, u minus something is another one. U plus something and u minus something. Did you understand that? U plus something and u minus something. Is that okay? U plus something and u minus something. Okay. And which is T, we can take T1 here and T2 here. And taking T1 and T2 here. Both of them are representing same distance. Both of them are representing same distance. This is T1 and this is T2. The one is T1, the other one is T2. Both of them are representing two times, but the same distance. They are representing 2 times, but the same distance. Okay. So the value of T, the first value of T will be T1. The other value of T will be T2. One value of T will be T1. The other value will be T2. Which is the greater? T2 or T1? Which is the greater? This is time. So what is greater one? T1 or T2? Which is the greater one? T2. T2 is the greater one. T2 is the greater one. So this is T2 and this is T1. Right? This is T2 and this is T1. So what will be T2? How can you find T1 and T2 from this equation? I can find T1. What will be the value of T1? T1 is the lesser value. T1 is the lesser value. So U minus root of U square minus 1600 divided by 10 will be T1. Okay. Then what is T2? T2 will be the next value of T and greater value of T. So U plus U square minus 1600 divided by 10 will be T2. So you have T1 and T2 now. But you have another idea from the question. What was the next idea from the question? What is the difference between T2 and T1? That's in the question. What is the difference between T2 and T1? That's 6 seconds. The time interval is 6 seconds. It is given in the question. So T2 minus T1 will be 6 seconds. What is T2 minus T1? That must be 6 seconds. Okay, so we have T1 and T2, and T2 minus T1 is what? T2 minus T1 is 6 seconds. Right? We can find what is T2? T2 is this one. U plus root of U square minus 1600 divided by 10 minus T1 minus T1 minus T1. This is T1. U minus root of U square minus 1600 divided by 10. Then that will be equal to 6. You got it? That will be equal to 6. Then what is this? There is a U, there is a minus U. There is a U, and you can see another minus U, U here, minus U here. So that will be gone. U is gone. Okay? And this is what? Minus, minus. It will be plus. And it is the same value. It is the same value. So this plus the same one. So that means 2 into this one. 2 into U square minus 1600 divided by 10 will be 6. Did you understand that? And what will happen to this 2? What will happen to this 2 and 10? That will be just 5. Just 5. Because this root is not for 10. The root is not for 10. Root is not for 10. Right? Okay. So you have 5 here. You have 5 here. What is U square minus 1600? You can bring this 5 to the other side. 6 into 5. That will be 30. 30. Right? And what is U square? What is U square? U square will be, yeah, 30 plus 1600. 30 plus 1600. Yeah, let it be there. Let it be there. Okay, I want another space. Can I move to this one? Can I move like this? Okay. Okay, then there is a square in it, right? There is a square in it. Okay, so I will write it. What is this? Root of square root of U square minus 1600 will be what? We can bring this 5 to the other side, then that will be 5 into 6. That is 30. Right? How can you remove the square root? How can you remove the square root? Just square it. How can you remove the square root? You can just square it. If you are squaring it, you can remove the square root. So the square root is removed. U square minus 1600 will become, you have to square the other thing. That is 30 square. What is 30 square? What is 30 square? What is 3 square? 9. And you have to give 2 zeros. If you are squaring a value into 1 0, in the result there will be 2 zeros. So 900 will be the value. 900. Then what is U square? U square. You can bring this minus 1600 to the other side. Then that will be 900 plus 1600. What is that? What is 16 plus 9? 16 plus 9. Yeah, that's 2000. 2500. That's 2500. Okay. And that's U square. What will be U? U will be square root of 2500. What is that? What is square root of 525? 5. 5. And square root of 0, 0. 0. Square root of 2 zeros. That's 0. So that will be 50. 50 meters per second will be our value. It will be our answer. Okay? You have to understand something. In this chapter, from this chapter, any type of questions can be formulated. The question actually coming from this chapter is pretty difficult. But your exam this year will be school exam. And you don't have to expect that much difficulty in the exam. They will not give you that difficult questions, right? But if you are appearing for a competitive exam, such type of questions can be asked from this part of the chapter. This is very risky to understand and do. Okay, this is such a type of question. I included this question to make you understand that there can be such type of questions, right? Have you done this type of question in school? Yeah. This type of question in school, Sana, Arpita, Sneha, have you done this type of questions in school?
No, sir.
Yeah. One example only. Okay. Then do this question. Do this question. It is very important actually. Important to understand there is concept like this. Important to understand there is concepts like this. So you should write this question. Write this question. Okay. Tell me when you have finished. Okay. I know this question is a little complicated. Okay. I'll just repeat it again. You just continue your taking the note. Continue your note. And in the question, it is saying that an object is projected vertically up. So the object has projected vertically up, and that object covered or meet 80-meter height 2 times. So that's 80-meter height 2 times. So that will be A and point B. Point A and point B. Okay, point A and point B. That means this is time T1 and time T2. Okay, from this equation S equal to UT plus half T square, you can find the value of T. This is S. S is 80. U t plus half at square. Acceleration is always negative. A is always minus g. A is always minus g in the case of upward motion. Okay. So A is equal to minus g, and you can give minus g here. When you are cutting the 10 and 2, you will get 5. So you will get a quadratic equation here. While bringing this minus 5t square and ut to the other side, you will get to 5t square minus ut plus 8t is equal to 0. That's your quadratic equation. You can solve your quadratic equation using this equation. X is equal to minus b plus or minus root of b square minus 4ac divided by 2a. So our equation will be like this. T is equal to that thing. Minus of minus u. That will become plus u. Plus or minus root of b square, that's minus u square. You will get u square here. Minus 4ac, that's 1600. Divided by 2a, that's 10. That means you will get two values for time. Two values for time. Two values for x. And first value will be t1, second value will be t2. Lesser value will be t1, greater value will be t2. Lesser value will be t1, greater value will be t2. So what is t1? U minus that thing. What is t2? U plus that thing. And you have t1 and t2. You have another idea also. What is that another idea? t2 minus t1 is the time interval, and it is given in the question. So t2 minus t1 is equal to 6 seconds, and that's t2 minus t1 is equal to 6 seconds. Okay, then u minus u is gone. This thing minus minus will be plus. So 2 into that thing. So 2 into that term is equal to 6. Okay, 2 and 10 is cut, 5 is the left, and we are bringing 5 to the other side. That will be 6 into 5. We will get 30. And you have to remove the square root. So you can square it. If you are squaring it, you will get this term. If you are squaring it, you will get this term. Okay. And if you are squaring it, you will get 900 on the other side. And the square root is gone from here. Square root is gone from here. So u square minus 1600 is equal to 900. You are bringing minus 1600 to the other side. You will get 2500. 2500. And you are taking square root of it, you will get to 50 meters per second. That is asked in the question. That is asked in the question. Have you taken the note? Arpita, Sana, Sneha?
Yes.
Can I move to the next question?
Yes, sir.
Okay, good. Then I am moving to the next question. Let's see question number 27. Question number 27. Question number 27. Look at it. Question number 27. What is question number 27? A particle is projected to be vertically upward. So a particle is projected and it is vertically upward with a velocity of u, the velocity of 40 meters per second. With a velocity of 40 meters per second. What is the displacement and distance traveled by the particle? What is the displacement and the distance traveled by the particle in 6 seconds? What is the displacement? What is the displacement and the distance traveled by the particle in 6 seconds? In 6 seconds, T is equal to 6 seconds. That's the question. Okay, how can we do this? How can we do this one? You have this idea. A particle is projected vertically upwards with a velocity u 40 meters per second, right? Right? This is upward motion, so acceleration is always negative, minus g. When this particle has reached its maximum position, the maximum position velocity will be 0. So there is only one data here, and from that one data, we can find the maximum, the condition for maximum velocity. From the condition for maximum velocity, we can find the height it has traveled. You can find the height it has traveled. Then that will be the distance from this point to this point. That will be the distance from this point to this point. What will be that distance at maximum height? at maximum height. At maximum height, velocity becomes zero. You know that. At maximum height, velocity becomes zero. You know that. And what is the equation there? That will be u square. V square is equal to u square plus 2as. Right? But in this case, v is zero. U square is what? U square is 40 square. That's 40 square. U square is equal to what? That's 40 square. U square will be 40 square. And 40 square, then yeah. But the acceleration, yeah, we will try it. We will try it. 40 square minus 2 into acceleration is g. G is what? G is 10 meter per second square. So that's 10 into s. You will get it. You will get s from the equation. Okay. What is s then? This is 40 square. 4 into 4, that's 16. You give 2 zeros. Minus, what is this? 2 into 10. That will be 20. 20 into s. Okay. That's 0. Then you can bring this minus 20 to the other side. You will get plus 20s. So plus 20s is 1600. Right? So what is s? What is the value of s? Value of s will be 1600 divided by, can bring this 20 to the other side. 1600 divided by 20. Then this 0 is gone. Okay. 160 divided by 2. What is s? What is s? S will be 160 divided by 2 will be 80. 160 by 2. That will be 80. So 80 meter. The maximum height is 80 meter, right? The maximum height is 80 meter. Maximum height is 80 meter, but it is just to find maximum. What is the displacement and distance traveled by the particle in 6 seconds? It is just asking for us to find the displacement and distance traveled. Displacement and distance traveled. How can we do this? Distance and this is maximum height, but the time is not here. In 6 seconds. In 6 seconds. This is maximum height, right? So that you have to include this one. You have to include this idea also. Time is 6 seconds. So you have to include that idea also. You don't have to find maximum height. You don't have to find maximum height. You don't need maximum height. What do you need to find? The distance and displacement in each second. T is equal to 2 seconds. Right? Let me give me a minute. Give me a minute. Yeah. Yes. Let me see. What is b square is equal to u square plus 2as, and that's 0. S is 40 square minus 2 into 10 into s. Then like that, 1600 minus 20 into s, that's 0. 20s is equal to 1600 and s is equal to 1600 divided by 20, right? So it is gone. 160 divided by 2 will be 80 meter. That will be 80 meter. So S is 80 meter. S is 80 meter now. Okay. S is 80 meter. So what will be the time taken here? Time taken to reach maximum position will be time to reach maximum position. Time to reach maximum position. Time to reach maximum position. What is the time taken to reach maximum position? You can use this equation S equal to ut plus half a t square. Right? This is S. So we have S is equal to U. U is 40 into T plus half into A is what? A is minus G. Minus G into D square. You can find the T. You can find the T from here. That will be 80 is equal to 40T. This 5, 10 and 2 can be cut. You will get a minus 5 here. So 5 minus 5T square. That will be an equation. That will be an equation. So I can bring this minus 5T to the other side. 5T minus 4T plus 80 is equal to what? That will be 0. And you can cut this value with 5. You can cut this value with 5. What will be that? We are cutting it with 5. This is gone. So t square minus 8t plus, what is it? 80 divided by 5 will be what? 130. 16. So 16 is equal to 0. You have to get 16 when you are multiplying, and you have to get minus 8 when you are adding. What is that? Which value will give you 16 when multiplying, and when adding it is minus 8? What about minus 4? Yeah. That's it. Minus 4 into minus 4, right? Minus 4 into minus 4. If you are giving minus 4 into minus 4, then you will get 16. Minus 4 into minus 4, that will be 16. Minus 4 plus minus 4 plus minus 4 will be 8. So that will be t minus 4 into t minus 4 is equal to 0. That means t is equal to 4 seconds. T is what? 4 seconds. That means the time to reach maximum position is 4 seconds. What is the time to reach maximum position? That's 4 seconds. So time to reach maximum position is 4 seconds, and it is traveled. No, it has traveled. This is maximum position, and it is going to come down now. It is going to come down now. Okay, it is going to come down now. I will just take that case also. The time difference is the total time. We have to see total time 6. Time is 6, right? Total time is 6 seconds. If you are taking the time to reach here as 4 seconds, then up to this is maximum height, right? This is maximum height. This is maximum height. So this will be 2 seconds. That will be 2 seconds. Total, you will get 6 seconds. Now, what will be the distance traveled in 2 seconds? Distance traveled in 2 seconds. What will be the distance traveled in 2 seconds? You can use this equation. S equal to ut plus half at square. What is S? That you have to find. S is equal to u. U is equal to 0 here. We are considering the downward motion. U is equal to 0. So u is equal to 0 plus half into A. What is A? Acceleration. We are taking the velocity in downward direction, and it is positive. I am taking it is positive. If it is positive, then acceleration is in the same direction. So acceleration is again, it also is positive. It also is positive. So what is that? Acceleration is positive means that will be A will be G. So that's 10 into T square. What is that? T is 2. We know the value of T. So that's 2 square. 2 square. And what is this? S is equal to 5 and 10 and 2 is cut. You will get 5 here. So 5 into 2 square. That's 4. 5 into 4. So S is equal to what? S is equal to 20 liter. S is equal to 20 liter. S is equal to 20 liter. Okay? S is equal to 20 liter. I will draw the rest here. S is equal to 20 liter. Okay? So here you have 16 meter up to this point and 20 meter from the maximum height to this point. The total travel time is 6 seconds. So what is the total distance? Total distance traveled will be in 6 seconds. What is the total distance? Total distance will be 60 plus 20. What is that? 60 plus 20. What is that? 80. So total. That's not 60. That's not 60. That's 80, right? That's 80, not 60. 80. So what is it? Total distance. Total distance traveled is what? Yeah, total distance traveled is 80 meter plus 20 meter. That will be 100 meter. And what is total displacement? What is total displacement? What is total displacement? It has started from this point and it has reached this point and it is returning from that point. So what is total displacement? Yes, 80 meter minus 20 meter. So you will get a 60 meter as total displacement. Did you understand this one? Did you understand this one? Okay, then you can write. Then you can write. If you have understood that, please take the note. Please take the note. When is your chemistry class? Okay, then you can leave. Then you can leave. I will write that in the tab and I will send that to you. Okay? Arpita, Sana, Sneha.
Okay.
I will make this into a tab. I will make this note into a tab and I will send you that in the form of a PDF or a photo. Okay? I told you chemistry class is 3:45. Why didn't you tell me that? Did you understand this one? How to do this?
Yes.
Yeah, okay. You can leave now. Then you can leave.
Thank you.
You can leave and join chemistry. Okay?
Thank you, sir.
Okay, thank you. Thank you. I'll write it in the tab and I will send you. Okay? Thank you. Yeah.